to write it in the form z minus the center. You're going to write it as minus, can be written as 0 minus 5i. As the modulus is equal to 3. And so the radius is 3, and the center is 0, negative 5.
0 and negative 5.
So looking for 0, negative 5.
D, sir.
D. Very good. So that's D.
0, sir, can the option D?
There it is.
0 on the x-axis, negative 5 on the y-axis.
Yeah.
Where you get the radius? So where you plot the circle?
Repeat.
How do you plot the circle?
Where you plot the circle.
Yes, sir.
So remember we looked at this, you know. So how did they get this locus to be in a circle? Remember when we looked at locus? We looked at locus and we said if you have, how we them get it to be a circle? The modulus of z minus a is equal to some number r. If you can get rid of the modulus by squaring both sides. And so you have z minus a is equal to r squared. Right? And a, remember, is a complex number. A is a complex number. A is a complex number. So this is really z minus some complex number. Let's call a complex number. I don't know. Let's call it px plus qi. And that's equal to r squared. And so z is equal to r squared plus px plus qi. And then this z, you can let this z be x plus yi. X plus yi is equal to this side, right? And so what you're then sketching is this complex number being equated to this. And it works out to be a circle. Remember, we looked at complex numbers from that long time. But the general rule is this. General rule. This is the general rule. If you have something like if the modulus of z minus a is the modulus of z minus a is equal to r, then z, then the locus of z is a circle with center a and radius r. So that's the keynote to catch from this question. All right?
So 0 and negative 5, sir.
So 0 and negative 5.
Find the point between them. Then we find the point there on the graph, sir. All I do.
So
but then again, how would I find the radius is 3.
The radius is 3.
The radius is 3. It's from the point to radius 3 and then draw a circle.
You just draw one circle. But the trick is to find the center, because notice all of them is a circle. All of them have radius 3. So the trick was to find the center. Question 3. What's question 3? What's question 3? How do this so many times?
Yeah, don't remember now.
Question 3 is A. So just to work it out again, it would be I times 1 plus I all square is working out to be 1 plus 2I minus I square, well, plus I square minus, this bracket is working out to be 1 square is 1 minus 2i plus I squared. So all of this is working out to be I times, in bracket, now 1 minus 1 cancel, 2i minus 2i is 4i, and then I squared minus I squared is 0, and so we get I times 4i, which is 4i squared. But then I squared is negative 1, and so we get negative 4. All right. We've done this so many times that we should be able to just can do these questions without work them out. Just shade answer. That's what we should start do. Let's just shade some answers. What's question 4?
C, sir.
C. Yeah. Question 4 is
The
C.
thing is, sir, I might not remember the answer right away, but I just know how to work it out. You know?
Yeah, that's always the best thing to know, how to work them out. Right? That's the best thing.
I don't know how to work it out, I'm good.
What's question 5?
B, negative 1.
Nice.
Negative.
Negative 1.
Ooh, water.
These are all repeat questions. What's question 6?
B.
B. Very good. Very good.
Ooh.
Sharp.
Sharp.
Yeah, sharp. That's how I like to see it. So as them question you repeat, it does a shell them back. Easy. What's question 7?
So as long as I know how to work them out, I'm good.
Question 7. Question 7 is a repeat too.
A.
A. Very
Right, so
good.
1 over x to the minus 3. No. 1 over
Sir, for
x
that
to
question,
1/3.
sir.
Yeah, question 7.
Sir, how you got the negative?
All right, let's look at question 7. So question 7 of ln x raised to the, what's that? Ln x raised to the 1/3. And we're differentiating ln x raised to the 1/3. So let's call this y. Right? So for log function, dy by dx or y prime is going to be equal to, if you have ln u, it is 1 over u, which is 1 over x to the 1/3, times du, which is the differential of x to the 1/3. Now the differential of x to the 1/3 is going to be 1 over 3 times x to the minus 2 over 3. And so y prime is actually equal to this x to the 1/3. You're going the numerator to become x to the minus 1/3. And then when you're multiplying with the same basis, it's pretty much addition. So it becomes plus minus 2 over 3. And remember, we're actually multiplying it by 1/3. So let's put the 1/3 on the inside. So it is 1/3. 1/3 minus 2/3 is minus 1. So it's x to the minus 1. And so this works out to be,
What's it?
Yes, sir. So that's why I'm asking how you got the negative.
yeah, very good. There should be no negative there. It should be 1 over 3x. Nice. Very good, Cheyenne. Sharp. Oh, that's very sharp. So this is 1 over 3x. So again, it shows importance of sometime you remember a question and maybe it's not the same question you remember. That's 1 over 3x. Question 8 is a repeat. What's question 8?
Could I just go back on the work?
Go back on the working out?
Yes, just for a second.
All right.
Okay, so.
All right. Question 8. What's question 8?
C.
C. Nice. It's a repeat. It's C. All right. What's question 9?
Dog.
D, that's right.
Dog. Yes, sir.
All right. Question 10. Everybody know
Number 8.
question 10. Question 10 repeat way too much. That's question 10.
B.
Boy.
Yes.
Yeah.
Oh, yes, sir.
Boy.
Repeat way too much. All right. Question 11.
Question 11.
C.
Yeah.
I think it's C.
I look like cat, you know.
Yes. Question 11 is C. This is the sum of two cosines. So you have to just remember the sum of two cosines is
2 cosine of A plus B over 2 sine A
where you get
plus A
sine
minus
from?
B over 2.
Where you get sine from? So this is it. We're saying cosine A plus cosine B
Oh,
is equal to 2 cosine A
A plus B
plus
over
B
2
over 2 times
cosine
cosine of A
A minus B
minus
over 2.
B over 2. Exactly. That's the formula for the sum of two sines, sum of two cosines. And so if they wanted, that looks like 8x and 2x as the two cosines we're adding. And so we just replace A with 8x. So we have cosine 8x plus cosine 2x plus cosine 2x. That's equal to 2 times the cosine of 8 plus 2 is 10. 10 divided by 2 is 5. So that's 2 times the cosine of 5x. 2 times the cosine of 5x. This doesn't look like cosine. 2 times the cosine of 5x times the cosine of x. Then they divide out 2. Then just divide it by 2 to get a half. This 2 gone. That's that question. Question 12. Big repeat. What's question 12?
C, sir.
C.
C. Nice. Repeat from the last paper as well. Question 13. What's question 13? This is a repeat.
D as in dog.
D as in dog. Yes. Nice. Question 14. What's question 14?
Boy.
Yes, it is boy.
Boy.
Yeah, that's question 14. All right, what's question 15? I honestly don't remember question 15. That looks like a brand new question to me.
No, sir, you just beat in the other one.
Question 15?
It's not brand new,
Yes,
but I
sir.
remember. What was that?
I can't remember that one. So integrating tan square over 4. So integrating from 0 to pi of tan square over 4, tan square x over 4. I'm going to bring out the 4, put as a quarter on the inside. So that's what we're doing. But the integral of tan square is sec square. So we'll get a quarter times the integral of tan square x is tan square plus 1 is sec square, and so sec square minus 1 is tan square. So we're integrating sec square x minus 1. That's the integral of tan square. But then when you integrate sec square, we get tan. So this works out to be a quarter times tan x minus x. And we're going from 0 to pi. So put in pi. The tan of pi is, what's the tan of pi?
0.
0. And so we get we get 0 minus pi minus 0, and so we're getting minus pi over 4. I've never seen this question. I don't know why. Don't feel like I've ever seen that question before. That's minus pi by 4. That's A. We've done this question?
So I think so.
Never, well, it feels new. Question 16, we just did that one. What's question 16?
C.
Wait, sir. What's number 15?
A. Question 16 is C. Very good. Question 17, we just did that question. What's 17?
Boy.
D.
Yes, nice. All right. Question 18, given that
E.
UN, what's 18?
C.
B?
No, sir. Cat.
Cat, yeah, cat. Cat sounds right. The reason why it is cat is, now this one is going to be alternating. So it is cat. So remember, there are two ways to show that a sequence is converging. But the easy way, what we said, is just to try large values. So try a large value like n equal to 1,000. And see if it's going to 0. So when n equal 1,000, this definitely not going to 0. When n equal 1,000, you get minus 1 to the 999. That's going to give you minus 1 times 2, which is negative 2. And so this is alternating between 2 and negative 2. Put in a large value like 1,000 right here, you're going to get a very small fraction. You're going to get very small fraction. So it is C. As you get bigger and bigger for n, this one is going to 0. So it's C. Question 9.
So when I said 2 minus 1,000, sir,
Repeat.
negative 998, don't it?
When I say 2 minus 1,000,
Yes, sir.
yeah, you get negative 998.
So when I plug in n equals to 1,000, what's the answer I get for un?
Remember, I know this is just trying, but yes, when you plug in 1,000 here, you're going to get 5 minus 3 times 1,000.
So 5 minus 3,000.
And you divide it by negative 998. You're going to get positive 3, right?
Yes, sir.
You get positive 3. If you try another n, try another bigger value for n now. So you try another bigger value like 10,000. I guarantee you're going to get a number that is smaller than 3. Then you try another bigger number, you're going to get a number that is smaller than that number. And so it's eventually converging to some number. This number looks like 5 over 2. It's converging to 5 over 2.
I think it's 3.
It's converging to 3? Yes, so
Yes,
it's
sir.
converging to 3. It's converging to 3. That's right. When you divide through by n, yes, it's 3. It's converging to 3. Nice.
It's 3.
Yes. Question 19. What's question 19? We've done this so many times. What's question 19?
What did I get for this again?
Minus 3. I guarantee it's minus 3. So how we do it again? We have to find A3. A3 is A2 minus A1. 3 minus 2. 3 minus 1 is 2. Then we have to find A4. A4 is A3 minus A2, which is 2 minus 3, which is minus 1. then we need to find A5, and A5 is just A4 minus A3, which is minus 3. Question 20. What's question 20?
If
A. You don't even need to work this out because if you're adding up all of these numbers, just to add these first three is 37. And so 37 could be the answer. All right, question 21. What's question 21?
dog,
Dog, yes, nice. So simplify this by saying n factorial is the same as n times n minus 1 times n minus 2 factorial. And so the n minus 2 factorial over the n minus 2 factorial cancel each other.
So what you get for number 20?
Number 20. Number 20 is A. Number 21. What's number 21? We just did this question. Remember, we were looking at 1 over I and 1 over I plus 1.
Yes, sir.
Oh yes, sir. We get dog.
It was dog. I remember we got
N
that
over n
answer.
plus 1, sir.
We got that answer was 1 minus 1 over n plus 1. And so to simplify
Yes, sir.
that,
And that one.
yes, that's
this
n,
one.
yeah.
Yes, sir.
Right.
21 and 22 is dog.
So you see the same question. Only thing is that the last time they asked for the limit, and this time they just ask you for the sum. Same question. Question 23. What's 23?
Where
What's
m is less
23?
than n.
What's 23?
See?
C.
Yeah.
So repeat again.
So how you do number 23?
All right, so we're going to do 23 again. So let's write it down. Sn is equal to the summation from, let's go back. It's equal to the summation from k equal 1 to n of k times k plus 1. It's equal to the sum from k equal 1 to n of k times k plus 1. And then they're telling us that for m less than n, m is less than n, you know, m is less than n. So if m is less than n, look what I'm going to show you. M is less than n. And so therefore I can write this now. This Sn can be written as the sum from k equal 1 to m of k times k plus 1 plus the sum from k equal to m plus 1 plus n, m plus 1 to n of k times k plus 1, that's equal to Sn. You agree with this? Think about it. Let's say m was 5, right? The sum from 1 to 5, then from 6 to 10. That's the sum from 1 to 10, right?
Oh,
yes, sir.
Yeah.
yes, sir. Yes,
And so
sir.
therefore, now this part now, when you're summing from k equal 1 to m, that's Sm. So this is Sm plus this thing is equal to Sn. And so all I need to do now is subtract Sm from both sides. And so I get Sn minus Sm. That's what it's equal to now. So we get that this thing right here since I call it dash right there, dash is equal to Sn minus Sm. That's clear now? That's clear?
Yes, sir.
All right. So that's another repeat question that they love to bring. That's C. Question 24. We do this too much time. That's 24.
Boy.
B.
Boy. Yeah.
23C.
Question 25. What's question 25?
What did I get for this
Dog.
again?
Dog.
Yeah, that's dog. What's question 26?
No, sir.
All right, so let's work it out. Well, you don't have to work it out. What you can do is try it in a calculator. But let's say everybody get 100 and they want to distinguish who is going to come first. To distinguish who come first, they're looking on who actually work it out this question. So 8 choose 3. 8 choose 3 is 8 factorial over what? 5 factorial, 3 factorial,
5
right?
factorial times 3 factorial. Yes, sir.
Now look what I'm going to do. I'm going to write this 8 now as 8 times 7 factorial over. Now I'm going to write this part now as, look at this. I can
So
write
what you gonna
5.
do? Multiply both. Why you multiply by 7?
I multiply by 7 factorial.
Oh, you rewrite it as 8 times 7 factorial.
Yes, I'm rewriting it as 8 times 7 factorial. All right? And then, look at this part now. Now, this 3 factorial, I can rewrite as 3 times 2 factorial. You agree?
Yes, sir.
5 factorial. So now, look at this now. I can factorize out the 8 over 3 part to get 8 over 3 times, in the numerator I'm left with 7 factorial over 5 factorial, 2 factorial. What's 7 factorial over 5 factorial, 2 factorial?
Oh, you pull out the 8 over 3. Oh.
Yep. Pull out the h over 3. What's 7
So
factorial?
it's 7 factorial over.
That's 7 choose 5 or 7 choose 2.
7 choose 2. That is 7 factorial over 7 minus 2 factorial. Oh.
And that's how you work it out.
Okay.
Easy question.
Yeah. Oh, I see it. I see it now, sir.
That would be cat. Is this clear? This is clear?
Yes, sir.
All right. So that's 26. 27 is another repeat. What's 27?
What is this answer again? I think it's 1 over 36 again, sir.
1 over 36. Yes, we've done this so many times. Nice. What's question 28?
A.
A. Nice. Question
yes, sir.
28. A. Nice. What's question 29?
What do we do this one again?
Is
Question
B.
29 is B.
a B,
Yes,
B.
B.
Why do that again, sir?
Read it again. There are 2 ways you can do it.
Oh, you can
Using
rewrite it as 1 over 100
binomial
minus 50x
expansion. Yeah,
all into the R4, and then you bring it up to the numerator, you solve it from there.
yeah. What's question 30?
Question 30, dog.
Dog, nice. Not a repeat question. Easy. All right. What's question 31?
Hey?
What's question
Appear letter
31?
me answer, sir.
Repeat.
Appear letter me answer. In how many ways can the letter P, Q, R, S, and T be arranged so that P and Q are always together and R
And
and
R
S
and
are
S
always
are
together?
always together. So they're saying they want P and
D.
Q. Go again.
Is it D?
D. Yes, it's D. Because we want
Can you
P
repeat
and
that,
Q
sir?
together, R and S together, and so they leave poor T. They leave poor T by herself. They leave T by herself. That's wicked to T. So this is a couple right here. It's a couple. And they leave T by herself. So in total, that's 3 factorial. But then the couple is 2 ways.
3 factorial
Couple is 2.
times 2 factorial times 2 factorial.
Exactly.
Oh.
That's it. Question 32. Big repeat. What's 32?
Why do this one again? Alright, so
We just
dog.
talk about this
Dog.
one. Dog,
No, boy.
boy, dog, which one?
Boy.
Ah, it's boy. Cannot be
Because
dog.
B now.
That's a negative.
Yes, sir.
All right, nice. Question 33.
Dog.
Dog,
Dog.
nice. Nice. Easy, soft. Imagine we just a fly through Cape like this coming soon. Nice, don't it? Question 34. What's question 34?
34.
For this one, I guess we're going to have to solve.
Let's have to work it out, sir.
So we have u squared.
D.
D, let's check it out. U squared plus 6u plus 9 equals 0. That's solving our auxiliary equation. And solving it, I'm getting u is equal to, that looks like
-3.
-3. And so the roots are repeated. And so we're getting y is equal to e to the minus 3x times a plus bx. And then they told us that when y is 0, x is 0. And so what they're telling us is when y
Wait,
is
sir, the roots are real and distinct.
real and equal.
And equal. Oh, equal.
Yeah. So that's 0 is equal to x is 0. And so
E
we're
to the
getting
0, which is 1.
1. So we're getting a is equal to 0. If a is equal to 0, then what we're getting is that y is equal to e to the minus 3x times bx. So that's b. The answer is b. That's B, that's B.
Yes, sir.
Oh my God, somebody's watching a nice African show. That's B.
So what's 30? It's a boy for number 34.
Question 34 is, yes, beta. Question 35. What's question 35?
0.9, dog. Because since you're mutually exclusive, 35, yes, sir.
0.9.
0.9.
Yeah, A, it is
0.1.
A. Yeah. it asks for the probability of S. Remember the probability of Q plus the probability of R plus the probability of S is going to be equal to 1. So S has to be 0.1. All right. What's question 36? This is a big repeat.
D, sir.
D.
So much time. E, easy. Question 37. What's question 37?
30. Sir, I get number 36.
Question 36.
Yes, sir.
Let us work it out. It says that a school debating team comprises of 3 teachers, 3 boys, and 3 girls. Are you choosing 3 teachers from 5 times? We're choosing 3 boys from 4, and we're choosing 3 girls from 6.
From out of 6.
That give you the 8.
Okay. Okay.
Yep. That's what we did. Question 37. Big repeat. What's question 37?
What is the probability that this person is female and prefers drink B?
A. We've done this 2 minutes.
10 over 28, right?
A. 1 over 6. So it says, what is the probability the person is females and prefer drink B? Female and prefer drink B, that's 10. So you're looking where drink B intersect female. And then it's divided by the total. So it's 10 over 60, which is 1 over 6. That's A. Question 38. We've done this too many times. What's question 38? It's question 38.
The first row of the product PQ.
I think it's C. So let's go. First row by first column is 2 times 2 is 4, plus 3 times 5, that's 19, minus 3. 19 minus 3 is 16. Now second row, and so we go this by this. Now we need to go this by this. So we get 2, 0, minus 2, that's 0. And so C is the answer for 38. What's 39?
I can go back for a second, please. Okay, thank you.
All right. All right, what's question 39?
So I'm telling you, some of them probability question are gonna treat me, you know.
It's not tricky. Look at this. It tell you AB, it tell you BC, tell you CD, then tell you ABC. Then ask you for the product ABC. The product ABC can be looked at.
ABCD, AB times CD.
It's ABC times D. ABC is P, and so ABCD is just P times D.
Okay.
Look at that. That's not even a math question. That's not even algebra. That's just substitution. See it here, the substitute ABC as P. Question 40. What's question 40? Question 40.
I think it's B.
That's B. Yes, it's repeated from the last paper. Just like 41. What's question 41?
Sir, with that question, so that team number 40.
B.
How you do it now? It's heads times heads. I say times n, which is less than 4. So how would you work out n less than 4?
So remember, the probability of n being less than 4 is the probability of getting a number that is less than 4. It's either you get 1, 2, or 3. So there are 3 numbers less than 4, so it's 3 over 6. That's the probability of getting a number less than 4. There's a 50% chance when you roll the dice, you're going to get a number less than 4.
Okay.
It just
So
times
I get
a
the
half.
others.
How I get the others now? The probability of head is a half. Probability of head is a half. And so therefore, the probability of getting a head, then a number that is less than 4.
So it's a half times
A half cube.
a half.
Half cube. Half times half times half. 3 times, so it's a half cube, which is 1 over 8.
Half times half times half. Oh,
Yeah.
okay. Can you reduce the 3 over 6 to half?
Another way to do it is to actually write down the sample space, but that would be too much work for a multiple choice. You could actually list out all the possibilities within your sample space. Question 41 is B, that's right. Question 42. So question 42, I don't know if it repeats. It's A?
Yes, sir.
So it repeats.
Oh,
No,
that's E.
I thought it's E.
The one is in the
Sir.
first order linear.
This one is A.
Because it's E to the integral
Of P
over X,
of P dx. So 2 over X.
which is E to the 2 ln
E to
X.
the
Wait,
2 ln X.
is it A?
C.
No, C,
C,
sir.
sir.
Okay, can rewrite it as E to the ln X squared.
Yeah,
And that's how equal to X squared, sir. So I can't.
yeah, cat. All right. Question
So it's 41 again.
41 is B.
Oh,
All right, question 43. Big routine. What's question 43?
A, sir.
the probability that L occurs given that K occurs. So how you did that now?
It's a conditional probability, and so it is the probability of L occurs
K.
given that K is the probability of L
So
given
K.
K.
So
That's
it's going to equal to the probability of L intersect K
L
over the
intersect
probability of
K
K.
over the probability of K. L intersect
So
K is 0.15.
5. Yes, sir.
And what's the probability of K? All of this is K. Remember, K is all of this, which is 0.6. So that's a quarter. That's question 43. Question 44. What's question 44?
0, A.
Why is it 0?
Because all of them are not scalar multiples of each other. So therefore the system is inconsistent.
Very good. It's inconsistent. If you were to times the first equation by 3, you're going to get negative 15 right here. And down here, you're not getting negative 15. And so the system is inconsistent. So it's the same question they repeat from last time, but the last time they had negative 16 right here. All right. Now question 45. What is true?
There are infinitely many solutions.
Oh, there should be infinitely many solutions. Look at it.
Or
What
the
is
system
it?
unique?
What is the last row saying? The last row is saying that 0x plus 0y.
Solution.
No solution.
No
0x
solution.
plus 0y plus 0.
0 can't
Oh
equal
yeah,
to
for real.
0 can't equal to And so the
What if-
solution is
All right,
UD.
sir. Look in the last row. What if a 0 was replaced with the 2, sir?
If
for the
there was
last
a
row?
0 right here,
Yes, sir.
then there would have been infinitely many solutions.
Okay. So there's no solution there. Sir.
So there's no solution right here.
Yeah, my fault right there.
Yep. All right. So that's it. So we went through 2015 and 2016. And so we have 4 more papers to do. We have 2017, 2018, 2019, and we have the specimen paper. We're going to go through the specimen paper because we don't know if they might take questions off the specimen paper this year. I just have a strong possibility that they might do.
So you did 2013?
Yes, we did 2013. Yeah, we did 2013 week before last week. Yeah, so what I'll do is I'll send you, I'll try to send, I'm going to look for the recording for 2013.
Okay, sir. Thank you.
Yeah. All right, so that's it. That's it for tonight. So I know some of you watching your movies, just don't stay up too late. Get some rest.
Oh.
And we have exam,
Okay,
and we have exam next week. So, you know, make sure to get in some studying tonight. Maybe 1 hour or 2. All right,
yes, sir.
and get all A's, all 1s. All right.
Yes, sir.
All right. So good
Yes,
luck
sir.
with your exams next week as well. And next week we'll continue with 2017 and
sir.
2018. All right. So have a good evening.
You too, sir.
Yes, sir.
Thanks for you, sir.
All right.